Dear students, in the last session, we have done the problem on superposition theorem. But in this session, I will explain the Thevenins theorem. It states that a complex linear bilateral network having active or passive elements with two terminals can be replaced by a simple circuit containing a voltage source called Thevenin's voltage source VTH and a resistance called Thevenin's resistance RTH connected in series with it. This is the Thevenin's network. That means actually states that in a complex linear bilateral network having active or passive elements with two terminals can be replaced by a simple circuit containing a voltage source called Thevenin's voltage source VTH and a resistance called Thevenin's resistance RTH connected in series with it. To find the Thevenin equivalent of a given circuit, first consider the given network. Step 2. Remove the load resistance and calculate the voltage at the load terminals, that is VTH. Step 3. By looking back from the load terminals in the network by replacing the voltage source by internal resistance and current source by open circuit, we can find the equivalent resistance, that is RTH. Step 4. Replace the entire network by a simple Thevenin source of voltage VTH and a Thevenin's resistance RTH in series with it. Step first, consider the given network. This is the given network. Step 2. To find the Thevenin's voltage VTH, remove the load resistance by open circuit in which current is to be found and find the open circuit voltage which appears across the two terminals where resistance has to be removed. That means VO equals VO, the voltage across the terminals A and B, VO equals I into R2. That means the current I is flowing in the mesh, in this mesh. I equals, V by R. That means that I equals E voltage divided by R1 plus R2, that means total resistance. We know the value of I means we can calculate the value of VTH. VTH equals VO, that means VTH in Thevenin's voltage equals the output voltage at the terminal A and B. That's equals E into R2 divided by R1 plus R2. Next, step 3. No. That means as the load is open, there is no potential drop across R3. Therefore, the potential difference between the terminal A and B is same as that of between X and Y. This voltage is called Thevenin's voltage. Next, find the equivalent resistance, that means Thevenin's resistance RTH, by looking back from the load terminals in the network by replacing the voltage source by the internal resistance and current source by open circuit. That means in this circuit, the voltage source is replaced by the internal resistance. This circuit can be extended by like this. That means the terminal A and B is stretched. It looks like this. The resistances R1 and R2 are connected in parallel, and these two resistors are connected in series. That means like this. Therefore, RTH equals R1 parallel R2 plus R3. Therefore, RTH equals to R1 into R2 divided by R1 plus R2 plus R3. Step 4. Replace the entire network by simple Thevenin source of voltage VTH and a Thevenin resistance RTH connected in series with it. Step 5. Finally, by connecting the load terminal, by connecting the load resistance across the terminals, A and B, and calculate the current at the load. Calculate the load current at the load resistance. That means IL. That means IL equals VTH divided by RTH. That means plus RL. That means total resistance RTH plus RL. Like this, we can calculate the load current. And also, we can calculate the voltage across A and B. So, VAB equals IL into RL. Thank you.